I'm Paul. I am a product manager at Google, and I work on AppScript among a couple of other products. I'm curious how many of you in the audience have used AppScript before or are familiar with it, or whether this is folks' first time. Awesome. So this talk is definitely designed for somebody who hasn't seen AppScript before, and it's an easy product to demo in that way because it's based on JavaScript, which is something that many or all of you already know. So just to tell you a little bit about myself, my broader team is the apps developer team, and we work on extensibility and automation and integration for G Suite. And I focus on AppScript in particular. I was previously a startup founder and CTO, and in that role and in this one, I know the challenge that comes with prioritization. I would imagine that we all have the experience of somebody approaching us with whatever level of urgency, telling us about the project that needs to get done or the process that needs to get implemented. And if the easy things aren't easy, then the hard things don't get done. That is to say, we have to prioritize ruthlessly in our jobs. And an easy technology lets us go from doing 5% of the things that we want to do to 10 or 15%. And that can be a really big difference for those users who are affected by that second 5 or 10%. I'm a big believer in serverless development. You've probably already been hearing a lot about serverless here at Next. It's something that Google is thinking hard about across the platform. And AppScript is one of the places and one of the first places that Google has championed serverless development. This is still my first year here at Google, but I'm excited to be solving some of these problems. I'm based in Boulder, Colorado, but I grew up in California, so I'm glad to be back. Okay, so this makes some assumptions about you. I know a little bit more than I did when I wrote this slide, which is that about half of you have used AppScript before. I'm also curious how many of you have formal engineering or software training. Okay, yeah, it's a slightly smaller set, and it's a slightly disjoint set, which is what we see. AppScript is something that gets used by people across the spectrum, and we like to see that. AppScript is part of a strategy for us that lets people solve their own problems. And so you may or may not have that formal training, but you have problems that can get solved using some, hopefully, a small amount of code. And you use or you want to use Google for your business, and you want to be able to automate and extend the products that you get as part of G Suite. So we'll talk quickly about what AppScript is broadly, what it's good for, and the actually several ways that you might use or have already used AppScript. And then this is a technical session, and so we'll talk about how to use AppScript, and we'll go through a few different use cases around a common theme that show you some of the different aspects of the product. One thing we won't dive deep into that's a super important facet of the product is add-ons. The next session in this room, who's given by one of the engineers on the AppScript team, which is given by one of the engineers on the team, will cover add-ons in depth. And so I don't want to steal his thunder, but please stick around if you're interested. And then we'll talk a little bit about features that we don't get to cover in the hands-on part of the session. And then I'll talk a little bit about where we go from here. So AppScript is a serverless JavaScript runtime for G Suite automation, extension, and integration. The first key part here is serverless. And serverless has as many definitions as it has people who use the word. But the key point is not that it doesn't run on servers. Obviously, it runs on servers. It's that you have no role in provisioning or managing those servers. I think another key piece of this, and this got talked about yesterday, is that serverless applications are event-driven. You don't have to proactively call this application from other code, because then you're still managing a server somewhere that's running some code. And so many of the use cases for AppScript are those where the code that you write is triggered at the right moment by user behavior, by a change to a document, without your having to write the code that triggers it. JavaScript. This is a key piece today, and at least for the near term, AppScript is written in JavaScript. And then the last part I want to highlight is G Suite affinity. That's not to say that you can't use AppScript to do other things. You can hit any RESTful API with an URL fetch call. You can talk to JDBC. You can talk to a bunch of Google services via our built-in APIs, or directly to their REST APIs via advanced services in AppScript. But our bread and butter is G Suite. And that means built-in APIs for talking to G Suite applications, for scripting Gmail, Docs, Sheets, Calendar, but also event-driven behavior based on those applications, and extensions and add-ons to those applications. So G Suite is really where AppScript starts. A few use cases, JavaScript is a Turing-complete programming language. You can do just about whatever you want to. But in the enterprise, this is really what we see happening. One way that I might summarize all of these, or some of these at least, is that these are applications that used to, or often still do, get done in Excel or in Google Sheets, where you have a spreadsheet that maybe has some macros or some scripts attached to it that is doing more than a spreadsheet ought to do. And frankly, that's often the way that an AppScript application itself evolves. You open the script editor in Sheets, you start typing some code, and before you know it, your spreadsheet is a mission-critical application for your team or the whole company, and you have built your first AppScript application. We'll talk a little bit about where you might go from there to add a UI on top of it and make it a full-fledged application. And I'll also touch briefly on AppMaker, which is a tool that was presented yesterday that's great for building UI on top of AppScript business logic. But key use cases, enterprise workflows, especially approval-type workflows, anything document-related. If you're on G Suite, you'll find yourself automating in AppScript often. Resource management, we internally use a tool that's built in AppScript to do project management on the Docs and Drive team at Google. Automation, this is anything from writing a little one-off script to setting up a time trigger to having a spreadsheet that generates a report on a biweekly basis. And reporting is right there on the list, too. And then with 3P integrations, too. If you want Sheets or Docs to talk to a third-party service, then AppScript is a great way to accomplish that. And then lastly, domain admin. We have some APIs that let you talk to the admin API. If you were in the AppMaker session yesterday, they mentioned a cool new Teams tool that's being deployed as an AppMaker template, and that's built on top of the admin SDK, which is accessible in AppScript. Okay, so there are 4 different ways that folks come to use AppScript, whether or not you're aware that you're using AppScript. And by far the biggest touch point is as the Docs, Sheets, and Forms script editor. So this is the script editor that you access by going to the Tools Script Editor menu in Docs or Sheets, or the vertical ellipsis script editor menu in Forms. That drops you into the AppScript editor in the specific context of that document. So that lets you write some code that operates on that document. You'll use the script editor when you have a script that has a special relationship to a document. And so this is that use case where the sheet is basically the front end to the application, or where you're adding some functionality to a document to build your table of contents, for example. And the way in which that special relationship is captured is with these 3 methods. And so depending on which application you're scripting, you'll call these methods to get an object representing the current document that you can use to act on that document. You also have access to simple triggers, which are super easy to code. You just define an onOpen or an onEdit function. That code runs every time that event happens to your document. And so onEdit in particular is good for doing complex work that depends on content across, say, a sheet. You might use custom functions for something piecemeal. And so you can also define a custom function that you can call in your sheet, and it'll operate on whichever cells you reference, where you call it in the sheet. If you want to do something that's more broad-based that sweeps in the whole contents of the sheet, you might look to the onEdit trigger. The entry point number 2 is directly at script.google.com. You'll notice if you go to Tools, Script Editor, you're editing a script at script.google.com, exactly the same product, just a different context. And by and large, you can do all of the exact same things in one of these standalone scripts that you can do in a bound script. Again, the decision tree is this script, does it have a special relationship with a particular document? If so, Tool Script Editor. If not, or even if in the future it might not have a special relationship to that one document, consider going straight to script.google.com and using other means to get access to the documents that you need to talk to. You can use the drive picker to get a drive file ID, and you can use the document app API to get a reference to whatever document you want to talk to in Docs, for example. And so that's kind of the first decision that you'll make when you're approaching AppScript is this script always going to be attached to this one document? Here are some of the things that you would do in a standalone AppScript project. You can just write a quick utility script. And so if you need to blast 50 emails or 100 emails to people in your org based on rows in a spreadsheet or some external data source, say, write it up in AppScript, hit the run button, test it out first, and send those emails off. You can also build web apps in AppScript, and this is something that we see leveraged particularly heavily at Google. A ton of the tools that we use internally are written in AppScript. When the user hits your web app, which is published at a well-known URL, it runs your AppScript code, and your AppScript code returns HTML back to the client. We have a templating system that lets you easily code HTML templates and populate them, and we'll actually do a deep dive on this later in the session, how you build a web app using AppScript. You can also build raw HTTP web services. It's not something that we'll go deep into today, but our execution API lets you invoke AppScript via a REST API, so you can build a backend service. Lastly, add-ons. As mentioned, that is going to get covered in CP304, which is the next session in this room. Stick around if you like what you hear, or maybe even if you don't, because he's cooler than I am. Okay, one place you may have seen AppScript before without knowing that it was AppScript is AdWords scripts. AdWords scripts run in the AppScript runtime and can leverage a bunch of the AppScript APIs. And then lastly, AppMaker, which I've mentioned, and which is being demoed across the street in Moscone West. Incredible tool for building web applications. AppScript sits behind AppMaker. Deployed AppMaker application is an AppScript web application. As such, it has access to all of the same APIs and facilities that AppScript does. When you write a server-side script in AppMaker, that is AppScript code that you're writing. If you want to learn more, I think the website is gsuite.google.com/appmaker, all one word. I definitely suggest checking it out. This is a team we work really closely with. Okay, so sorry, we're going to do some hands-on coding. I hope it's not too slow. Stop me if you're bored to tears. We're going to organize a speaker event. A little bit contrived, but it shows off a bunch of the stuff you can do with AppScript. By the way, we're not going to be following along our quick starts directly, but we are going to touch on these 3 types of scripts that you see featured in our documentation, and also up there is the web address. AppScript documentation is the best place to start, and certainly the place you'll be coming back to as you go deeper with AppScript. Okay, so we're going to proceed through 3 versions of the same application that introduce new types and levels of functionality. The first one is super simple. We're going to build Drive notifications for ourselves. And so we've got a folder. We've asked everybody who's presenting at the conference to put their decks in that folder for review and approval. And we want to get notified every time something new comes into that folder. Super simple use case, but a good jumping off point. All right, so first thing that we're going to do is we're going to grab the ID of this folder in Drive. This is our special folder. And then we'll create an AppScript project. Sorry, I should go back. You can go directly to script.google.com, or to create an AppScript project in a particular place in Drive. It's really handy to just go to the New menu, click More, and then Google AppScript. All right, so obviously you memorized the folder ID, and you recognize it here. So we've stashed that in a global. And we're going to do some processing on that folder. You'll see what we're going to do on one run of this script as I step through the code, and then I'll show you how we set it up to run on a time trigger so you'll get those notifications regularly. So the first thing that we're going to do is we're going to grab a folder object using the Drive app built-in API that represents that folder that I just showed you in Drive. This lets you script that folder in a lot of ways, and the way that we're going to do it is to look at what's inside that folder. You'll see when we go to install our trigger that runs this regularly, you as the developer are going to get asked to authorize access to Drive. And so everything that AppScript does, whether it's running as you, the developer, or as we'll see later on, if it's running as the end user, everything is authorized via OAuth. And so you or the end user know what data AppScript is working with. All right, so get an iterator over the files. We're also going to grab our script properties. Script properties is a store key value pairs for this script. You also have user properties, and in the context of a container-bound script, a script attached to a document properties. And so this is your very lightweight persistence layer for AppScript. When we get to the roadmap, I'll talk a little bit about our vision for storage in AppScript. But this is where you start today, and it works great for this use case. All right. So this is a while loop. I don't want to single anybody out. Does everybody in here know JavaScript like the back of your hand? Okay. So this is a while loop. This iterates over a set of code as long as the condition in the parentheses is true. And so file iterator has this method that tells us whether it has more files that we can look at. And we're just going to look at each file in this folder until we run out. Our strategy here is we want to know what new files are in this folder. That inherently is a persistence problem because we have to know what files we've seen before. And that's what we're going to use our properties store for. And so we're forming a key with the file ID. The file slash in the key name, that's arbitrary. That's up to you as a developer how you want to define your key. This is with the anticipation that you might put some other stuff in that properties store. And so you're just namespacing it. And then you're going to see if you've already put that key in before. If you have, that's because the script ran before and you already saw that file, no action required. But if not, then, you're going to set the property so you know you've seen the file, and then you're going to just push it onto an array. And so that push method is just adding your file to your new files array. And then lastly, if you found any new files, we're going to log that. And I'll show you what that looks like in the logger feature. And we'll send off an email. So this is demonstrating this script running as a standalone one-off script. I'll show you how to set it up and a trigger in a minute. But for now, we're just going to select the process method that we just defined and hit play. It's going to run. Now we'll go to the logs. And we see, indeed, new slides were found in that folder. We've got 2 decks in that folder. We go over to our Gmail, and we also see those 2 presentations listed there. Okay, so the last step to have true folder notifications is that you don't want to have to go and hit the play button every 5 minutes. And so in the resources menu, you'll find triggers for the project. Configure a trigger here. This is the permission step. And so because you're the person installing the trigger, the script is going to run as you. You're the person with access to the folder that it operates on. So that's by design. And you'll need to authorize access. And so this is the part where you know what kind of data this script is accessing. So it knows who I am, but most importantly are these first 2 where we see that it's gonna be able to look at Drive, and it's going to manage my email. In the roadmap portion of the talk, I'll talk about what we're doing to let you tailor these scopes more narrowly. And I want to call out that this first scope is broad. This is full Gmail scope, where this script, all it does is send an email. And so I'll talk about what we're going to do to make sure that you don't need to request this scope when you just want to send email. Save that trigger and off you go. So you now have folder notifications in Drive. It's a small use case, but it's also a small amount of code, and that's what we like. We want those easy things to be easy. This was a time trigger. And so in this case, we selected the time-driven type and ran it every 5 minutes. There are a few other kinds of triggers, some of which we'll talk about, some of which we won't. But it's a very similar mechanism to the one that you would use, for example, to write a script that looks up a document, whether one that's given to you by a user or selected using the drive picker, et cetera, and install a trigger on that document to get notifications when it changes. But in this case, we're just talking about a simple time-driven trigger. I should say, feel free to jump in and ask questions as you did anytime. Yeah.
Let's say you have a domain with 15,000 users or 20, I don't know, 100,000 users. I know there's quotas for the use of apps.
Yep.
I found really, well, I don't know, I'm not a developer, but difficult to calculate, for example, the triggers. No? If there's a lot of action going on that folder, how do I calculate, I don't know, the amount of in and out, transactions or whatever?
That's a great point. So linked in our documentation are the quotas for each of our APIs. When you write a script in this way that runs as the developer, that is something you have to think about because it will be the developer's quota that will determine how many of those calls you can make. That becomes an architecture question. Now, it's very unlikely, for example, that you as the developer would write a script that was processing a folder that was being accessed by everybody in the organization. On the other hand, you might be writing an application that lets somebody configure a folder or create a folder for which they wanted to receive notifications. At that point, you'd be writing a script probably that ran as that user, and it would be that user's quota who is getting absorbed. These quotas are designed to be permissive enough that you can get done what you need to do, and typically, your architectural decision about who the script should run as will dictate that it run as the user in those cases where there are going to be a lot of people impacted by it. But if you did find yourself in a situation, say you were building a web app that used your OAuth token to access some company-wide data and present it to the user, if that became a mission-critical application, you might have to think about how you would have that run as the end user instead and use their quota. When we get to the roadmap portion, I'll also talk about some of the work that we're doing on quotas to make them more flexible. Okay, so in this second step, we're going to work on a container-bound script. That's a script that's attached to a particular document. We're still working in the same context. We're planning a conference. We're still operating on a folder in Drive, but we've also got a sheet that has some metadata about the decks, about the sessions that are reflected in that folder. And so for every session, we're going to have the title of the session, which will also be the title of the document, a link to the slides, a username of the owner, and then comma-separated lists of approvers and people who have approved. And so if this is used correctly, which I have coded no checks to ensure that it is, but wanted to keep it simple, the approvals column will be a subset of the approvers column. That is to say, if John and Tim and Lisa need to approve, and John and Lisa have approved, then you'll see John, Tim, Lisa in approvers, and John, Lisa in approvals. Excuse me. All right. So you've set up your sheet, and you want to write a script that has a special relationship with a sheet. To do that, you go to the Tools menu and click Script Editor. All right. And so here's our script. Firstly, we've got the familiar folder ID global. We're still working with that folder. And then we've defined some globals for column indexes. Please speak up if you've used AppScript before and you have other ways of doing these things. There are many ways to skin these cats, and I would love to hear from other folks how they do these things. The other thing that we're doing here, and this is one of the cool things about working with JavaScript. Gmail app is just a global in the JavaScript namespace. Here, we're going to stub it out. We're going to replace it with our own implementation, and that lets us write a script that works with a sensitive API that sends email to people with the confidence that the first time we run it, if there's something wrong, if there's a typo, we're going to be the ones who see it instead of the recipient of the email. And so this is going to leverage logger.log, which is just a simple logging tool. I'll talk a little bit later about more sophisticated logging, and then there will be a session at 4 o'clock today that goes all the way down the rabbit hole on our Stackdriver logging integration, and that'll be over in Moscone. But here is simply stubbing out send email so that our script doesn't actually send emails until we're ready for it. All right, so first thing we're going to do, we're going to call spreadsheet app.getActiveSheet. I called this out earlier. This is the way that you get that document with which you have that special relationship. I've abstracted out find new files. It's the same code we saw previously. It's going to leverage property service to keep track of where we are and to identify new files in the folder identified above. The new code here is that we're going to iterate over those new files, and we're going to add a row to the sheet for every file that we see. And so the design here is that you might update the sheet directly, but if not, you'll get a row added as people drop their slides into the folder. And then we're going to iterate over all rows of the sheet, and we're going to do some email-based workflow. And so process row is the relevant call, and I'll show you what it does for each row of the sheet. Just jumping back briefly for some minutia, you'll notice that rows are 0 indexed, but we have a header row, so we're starting with row 1. I should say there are other, so we're calling getDataRange.getDisplayValues. That's going to return a two-dimensional array of the values of the cells in a sheet. There are other methods that allow you to grab a range. Those are not 0 indexed. Like sheets, those are 1 indexed. But when you're operating on a JavaScript array, 0 indexed. All right, so here we're doing some quick housekeeping. We're making sure that this is in good order. And so we're going to check that there's an owner for the row. And so when we discover a new set of slides in this folder, we're adding an entry in our sheet that has the title and a link to the slides. That obviously doesn't have any of the metadata that's only stored in sheets. And so we need to let somebody know that those rows need to be populated. And so those cells, excuse me. And so we will look for an owner. If there's no owner, then we'll contact the owner of the script, which is you. Once we know the owner, then we're going to look and see if we have approvers for the slides. Excuse me. Did I do that wrong? OK, so edit. Approvers column index on line 73 should be on line 64, and approvals column index should be on line 73. Apologies. And then we're going to check our approvals. And so this is the actual business logic. This is the workflow here. quick use of JavaScript split function to split up our approvers and our approvals values. So we have arrays of people who need to approve this and people who have approved this. And then we're going to iterate over our approvers, and we're going to check whether they've approved. Any approver who hasn't approved is going to get a notification reminding them to, hey, go check out these slides. We need your sign-off for this session. OK, so now we've got some data in this sheet. It may have been populated automatically by our script, or it may have been populated manually. And we're going to add a new session to our folder. Again, just showing you how you would run this manually. We'll run the process function. Here we get much more substantial logging. These are log messages generated by our send email stub, by our send stub. And so what you can see here is that this is a lot of activity that would have happened in the wild that would have generated real email messages if we hadn't stubbed out this method. It's a great idea for testing to put it in the logs first and make sure that these messages say what you want them to. And we see that our sheet has been updated. We've added a new row with a link to slides. Also in those logs, you would have seen messages going out to you requesting you to populate the owner for this new row. All right. So in the last step here, we're going to build a front end for our workflow engine. And so we're going to build some UI that is no longer running as the developer, but that runs as the end user, who's going to be somebody who's involved in the conference that we're planning and who has approval responsibility for one or more of the presentations. We'll show them what they need to approve, and we'll let them approve in the UI instead of going directly to the sheet. OK, so first thing we're going to do, we're going to add a new script file to isolate the logic related to our web app. This is going to be a script file, we'll just call it web app, that defines a do-get method. And sorry, it's covered up by the orange box there, but that's the magic name of a method in a web app that responds to an HTTP GET request. You can also define a do post for posts. Again, we're grabbing the active sheet. Here, so this do-get method does two things. It renders the list of sessions that a person needs to approve. It also processes the request that's generated when somebody clicks the approve button. And so here, we'll see some logic that's checking if an approval is being granted. And that'll be in the form of a URL parameter with the document URL. And so we're going to split up the document URL, and we're going to extract the ID of the document that's being approved. And so the request coming in to this would be your script's base URL, question mark, and then your doc parameter, that's just DOC as we've defined it, which will have a URL in it, which will be the URL of the slide deck that you're approving. We know that the URL of a slide deck has an ID for the document in it before the trailing slash. So we'll split it up, and we'll take the second to last portion of that URL, and we know that that's our document ID. So this is just how we grab the document ID that's being approved. Then we're going to call session.getActiveUser. And this is interesting. This is the part where we identify the person at the keyboard. This is not you, the developer, but this is the person accessing your web app. Because that person has a Google login and is signed in, their identity is already known. They will see an OAuth prompt because we're going to be looking at some data on their behalf. But the login flow is already, it's part of their Google login. And so we're going to grab that identity, and we're going to get their username as part of their email address. All right, so now we're generating our response. And the loop that we're about to walk through does two things. If this is the document that's being approved, we're going to update the approvers. We're going to add every document to an array of approvable documents, and we're going to use that to then render an HTML response that shows the list of documents that this user needs to approve. All right, so This is an example of using the getRange method on a sheet. Those methods are one indexed, not zero indexed. So just an important detail to remember. And we're going to grab the approver's value for the current row of the sheet. That's who needs to approve this session. We've abstracted out parsing the approvers. It's a little bit of a mouthful. But we're going to split on commas. And for the empty string, we just have to handle the case where we wind up with an array with one empty string in it. In that case, there are no approvers. And so just splitting up on commas. Here we're asking, is the current user an approver of this document? So remember, we're iterating over all rows of the sheet. We're only going to do anything for those rows where this user needs to approve our slides. And then we're going to grab the approvals. And then we're going to why are we checking again here? All right. Okay, so we are iterating over our approvals, and we're seeing if this approver has approved this document yet. If not, then we're going to include it in the approvables list. Excuse me, we're going to add it to the approvables list regardless. But we're also going to stash a value that tells us whether it's been approved. All right. Lastly, we're going to build an object. And so here, just for every row in the sheet that represents a document that needs somebody's approval, we're going to have an entry in an array that tells us the title, the URL, whether it's been approved, and then the URL that you would have to hit to approve it. And that's the URL with the doc parameter that we know how to process so that we can approve an entry in the sheet. Okay, cool. We'll look next at how we do templating. So here we are grabbing our HTML template, and we're shoving the data in approvables into that template and rendering it. This is just a classic separation of controller and view, of business logic from the view. And so here we know what our approvables are, and we know we're going to write a template that knows how to render those out to the client. And so we write this out. It's boilerplate. We call template.evaluate, and that's going to return our template HTML with values populated. So now I'll show you what that template looks like. All right, so you'll create a new HTML file. We'll call it page. This part gets written out for you, basic HTML. The interesting part here is the code that we write. And so we're going to render a table that has a list of the documents that need to be approved. It's going to have an action button that lets you, as the approver, approve a document. So here what you're saying is JavaScript code embedded in HTML. Angle bracket question mark is the escape sequence to do that. And so approvables here, if you'll recall, we've passed in to our template. And so properties of the template are accessible from within your HTML template code as JavaScript variables using that escape sequence. And so template.approvables sets that approvables array on the template. And it's this for loop here that iterates over those approvables. Now, once we close the escape sequence, we're back in HTML. And so we're just writing out a TR for every document in our list. And then we're going to render the control button to approve the document, or we'll render out a checkbox if it's already been approved. And so you'll see here in the second block of the if statement, if this document hasn't been approved, then we're going to render an empty checkbox, and that's going to link to that approval URL that identifies this document as the one that you, the end user of the application, want to approve. And then we're going to render out the title with a link to the document so that you can review it. Close our curly braces. Okay, so in the publish menu, you'll find deploy as web app. This is how you tell AppScript that you want this code to run in response to HTTP requests and to give you a well-defined URL that users can go to use your application. This is all it takes. You write some HTML, you write some business logic, and then you deploy it as a web app, and we'll tell you where users go to access that application. So a couple of key things here. Execute the app as the user accessing the web app. This is designed to be a user-centric view. And this gets to your question as well. This is a case where your quota is not going to be absorbed as a developer. If this were not conference planning, but vacation planning, and everybody in the company were using it, then you would only be absorbing end users' quota as they hit it. And then who has access to the app? We're going to allow everybody in the domain to access the application. And then we get our URL. And so this is the application URL. You may choose to map this with a URL shortener or even a subdomain. That's one way that we see folks kind of putting the stamp of approval on an application that's built using AppScript so that folks know that it's sanctioned by IT, by the folks who control the DNS record. All right, so now we're experiencing this web application as a user. The first step is going to be to review the permissions that it requires. Again, I'll talk about how we're working on this. This is a long list of permissions. The big ones, though, that you see are Gmail, Drive, and View and Manage Spreadsheets. And so here's what I see. These are the presentations that need my approval, where I'm in that list of approvers. And neither of these is approved, and so I have a checkbox next to each of them. After reviewing this presentation, I click the checkbox, page loads, we render again, and this time we render a check mark instead of an open box because I've approved this document. And here we see I've been added to the approvals column of the document, so the spreadsheet is up to date. What we've really done here is we've replaced the spreadsheet as an interface to our application with a web application that's tailored to the use case, and that also prevents the user from doing stuff that they ought not to do with this sheet. Great. So that was a walkthrough of kind of 3 key deployment types in the context of one use case. And just wanted to quickly touch on stuff that didn't get swept into it, because there's a lot. This product has been around since 2009, and it's grown significantly. So built-in APIs, we saw a few of these. We saw Drive app, we saw Spreadsheet app. There are about a dozen of these built-in APIs. They are designed to be ergonomic and accessible to people who don't write a ton of code. In most cases, those APIs mirror and are basically wrappers around a public REST HTTP API that you can use to talk to these services. We've packaged them up in an ergonomic, easy way. If you're familiar with J2EE beans, then the method naming pattern will be super familiar. It's a great way to quickly automate G Suite. We also give you access to other Google and GCP APIs as advanced services. Those are APIs where you do effectively hit them in the existing RESTful form. We just put some niceties around them in AppScript to make it easier to make those calls. We defines google.script.run. This is in the context of add-ons specifically. Again, if you're around for the next session, you'll see how this can get used to generate a call from the client side that runs code on the server side. This is also what you would use in AppMaker if you wanted to run a server-side script in response to a client event. Super easy to call any function that you've defined in AppScript from the client. The 4 o'clock session over in Moscone, we'll dive deep. Our Stackdriver logging integration is currently in EAP. Folks who are in the AppMaker EAP will have access to this feature. and it lets you log messages using the familiar console.log method. And those messages go to Stackdriver logging. And they're available for analysis and for monitoring. It's a super powerful tool for monitoring your application. And I would recommend it highly for anybody who's doing something sophisticated or that has lots of users. Logger.log becomes cumbersome when you're trying to work with more than one end user. Add-ons for doc sheets and forms. That's the next session. Custom menu items, sidebars, and dialogues for docs, sheets, and forms. And so you can define these in an add-on if you want everybody to be able to install them, or if you just want to build some UI around a particular document, you still have access to the same methods. You can add menu items. You can add a sidebar that has your custom UI. You can trick your sheet out to your heart's content with these custom UI elements in Sheets. You can define custom functions for Sheets. We see this used a lot in vertical-specific use cases, especially around finance, but others as well, to extend Sheets just with custom functions that do stuff that the built-ins don't. Both event and time-based triggering, we talked a little bit about both of those. And then you can use our execution API with an OAuth token that you obtain or generate for the user that runs in the context of that OAuth token the AppScript code that you've defined. And so this is a way that you would build a RESTful web service with AppScript that does something more than existing G Suite APIs do for you, that interleaves functionality of G Suite APIs, or that possibly brings data in from an on-prem or a third-party source. Here's the full list of, on the left-hand side, built-in services, some additional script services for programming primitives and JDBC, and advanced services. These are RESTful APIs that are scriptable in AppScript without using URL fetch to do explicit HTTP requests. All right, the fun part. The lawyers literally made me put this up here. This is the usual. This is where we think we're going and the timeline that we think we're doing it. No formal commitment, but the stuff that we're doing is important, so I hope we do it on the dates that you see here. So the first thing that we're working on is a step toward improving developer and end user visibility into the behavior of AppScript. Often your scripts run in the background in response to triggers. They don't have a UI. And whether to debug them or just to make sure that everything's going well, you want to see basically your top. You want to see your process list. And so this is something that's currently in TT. You can go and see all of the scripts that are running as you, various filters available with their result. It's great for debugging, but it's also great for, as an end user, understanding what's going on with the application that you use in your day-to-day. We're working on a new management and deployment API. This is geared toward more sophisticated users of AppScript and more sophisticated workflows. This is the way that you would use your own developer tools, and in particular your own source code management with AppScript. This API will let you push scripts into AppScript and deploy your AppScript project programmatically. You can use this also to do continuous integration and automated testing with AppScript. Write your code, commit it to version control, push it up to your dev server, deploy your dev server, make sure it works, push that code up to your production server, and deploy your production server with the new code. Explicit OAuth scopes. So this is something I mentioned a couple of times. Today, AppScript infers the OAuth scopes that are required to do the things that the script does. And so if you use Drive app, you're going to request Drive scope. If you use Gmail app, today we request full Gmail scope. This is the way that you can be more narrowly tailored. And it's just a first step toward being better about requesting kind of the minimum of access that an application needs, which is something that everybody cares about. This first step, you'll be able to list out the scopes that you want as an override to our automatically determining them. So you'll be able to narrowly tailor those scopes to exactly what your script is doing. just announced this morning, Gmail add-ons. This is in TT. Like Docs, Sheets, and Forms add-ons, Gmail add-ons will be written in AppScript. Unlike Docs, Sheets, and Forms, Gmail add-ons use a domain-specific markup to render cards. And the cool thing about that is that Gmail has written the code that renders the card, and that code runs on the web and in mobile. And so you, as a developer of a Gmail add-on, don't have to think about what's your UI going to look like in all these different contexts. You just render a card using their markup. And it displays images or links or lists, lets you add a bunch of richness around a message that matches your criteria for running the add-on. We're really excited about this. Slides app and Slides add-ons. So we're going to have a built-in API for scripting slides. It's long overdue. We're really excited to have it landing. And also the ability to build add-ons for slides in the same way that you do for Docs, Sheets, and Forms. There's a short link here if you want to sign up for the TT. If you use slides heavily, please give it a look. Batch and parallel jobs. This is partly in response to quota concerns. One of the things that developers run into when they try to do big jobs in AppScript is the 30-minute or 6-minute execution time limit, depending on what context you're running in. We are building out a service that lets us still maintain some of those important assumptions about the longest that a script could possibly run, but while letting you kick off a big job and not have to worry about how it gets split up between AppScript processes. And so you'll pass in an array of tasks that are just units of work. You'll tell us what function you want to run on each of those units of work, and then you'll tell us what function you want to run with the results of each of those units of work. And we'll split that up among AppScript tasks. We'll parallelize them to the extent that we can. This is intended to serve the use case of large batch jobs that would normally take a long time or consume a lot of quota. And then lastly, and a little bit further out, we're thinking about more developer and admin visibility. And that's kind of a high-level view of script health without having to dive into logs or just look at the most recent execution, to point you into the execution history you see in the process dashboard, but to let you easily navigate from lots of different scripts you work with, see adoption of your scripts, get notified of deprecations, et cetera. We are in the earlier phases of that project, but we think it's super important to let developers and then down-the-line admins have a lot of visibility into what's happening in their domain, whether their scripts are working, whether they're calling deprecated APIs, and so forth. All right. Just a few quick links to resources, depending what level you're working at. A great intro here first in the list, thanks to our own Wesley, is at 1SXEUD. I'll leave that up for a second so folks can snap a photo or write it down if you want to check any of these out.